Okay, welcome back, and we're going to do this, friends. So come back and we will do this together. Like making a grenade. Because that's awesome and makes everyone happy, like smiley face, like right there. So, and what we're doing right now is we're looking into something called Lewis dot structure. Now, Lewis dot structure probably named after some guy named Lewis. Just guess. So, what he's doing is he's showing the number of electrons that any particular element can either give away or take. Now, this is where we were making, let's say, balanced compounds. So in the balanced compounds, notice that we have, let's say, aluminum, and we said that aluminum make +3 oxidation. Well, that's largely because it give away 3 electrons. Goodbye, -3 electrons. That makes aluminum +3. But if we want to show this visually, we show that aluminum has 3 electrons to give away. Now, right about here, we'll make dividing line. Right about here, this is where atom no longer want to give away, but would rather hold on to and accept more. For look, remember we used to say nitrogen make a +3, which is true because nitrogen has place for 3 electrons. Oh, actually, I should say -3. Because if it's bringing on board more negative electrons, well, it's going to be negative, more negative than normal. So this is where draw boxes. It's called Lewis dot structure. Oxygen. Remember we always say oxygen, -2? You shake head like you pretend. Yes, I remember. Okay, so this is why there are spaces for 2 electrons. That's what make it -2. Fluorine. Fluorine have space for 1. That's why we say everything in this column is -1 because it hold on to 1 electron. Now these guys right here, these are snobs. These like Kardashians of periodic table. Because they do not interact with no one because look, they have no spaces to accept electrons. All electrons paired. See, all paired. No room for anyone else. Dense card full. That's why Kardashians not do anything besides tweet because they cannot talk to anyone else. They have no time. No time. So in these guys here, they give away electrons to try to get to what we call the perfect octet of 8. Having 8 makes you very Kardashian-esque. Ish, sort of. So, though they are cheating and taking on more, they still now have all 8 electrons and that make them happy, even though they are now in debt for life. Okay, so this Lewis dot structure, sort of like freckles on atom, tell you how many electrons can be accepted or given away. And just like the charges, they are all same in columns. So you find column, they all be same. Okay, this one here you have little bit experience with, maybe, sort of, perhaps. So we have done where we give you grams and then I ask you how many moles. Now, as you recall, the mole we talk about is not a furry animal that comes out of ground with big buck teeth. That's not the mole we talk about. We talk about mole that has quantity of something. A mole is exactly this amount right there. And that is referred to as Avogadro's grenade. Avogadro's number. Now it's a big number. It's sort of like dozen, just way, way bigger. So this is number of things that make up mole. So right here, what I would suggest is perhaps copy this down, because it gives you secret cheating way to convert between grams, which is what you would measure out in, let's say, chemical stockroom, and moles, which is what you use to do chemical reactions with, to you predict how much you will make, like recipe. So if you want to go from grams to moles, you take your grams and then you use this. You multiply 1 mole over the number of grams that that molecule is. So for example, if you have 18 grams of, let's say, H2O, which is your friend and mine, water. It's great. Actually, you know, the funny thing is in Russian, the way you say vodka in Russian is voda. Sounds a lot like water, doesn't it? Vodka, water, it's all same. So you multiply, so molar mass goes down here over 1 mole. Now, if you do it exactly like this, this one here, this would be 2, because you have 2, and hydrogen is a molar mass of 1. This one is 16, so 2 plus 16 is 18. So you would have 1 mole over 18 grams. And as that turns out, look, so 18 times 1 over 18 grams, that gives you 1 mole. I know it's crazy, right? Now, if I want to know how many particles there are, so if I have 1 mole of water, how many particles? Well, then I take my mole and multiply it by this, exactly as written. This number, Avogadro's number, over 1 mole, and that gives me number of particles or molecules or atoms or whatever it is I'm looking for. And do exactly opposite if I want to go back this way. So say, for example, I have reaction that says I made 3 moles of aluminum. Okay, so how many grams is that going to equal to? Well, we take grams of aluminum, which is 27 grams per 1 mole, multiply by 3, and that tells us how many grams we have. Now, this in normal life would be like video you could pause. Just pause, like that. But because we are doing live, you can copy this down later. Because we have to move on and whatnot. Now this is normally where I put in boss-like video. And then we go disco, disco. This is probably good stuff drug dealers need to know. So it's like Colombian chemistry.
Here they come. All right. I spotted it.
You are looking at an Atari 2600 emulator that I built in Minecraft. So here is Pac-Man for the Atari 2600. It is widely regarded as being one of the worst ports to the Atari.
Merry Christmas, everyone, from Snug Harbor on Prosperity Farms Road and their traditional Christmas display.
Now, this stuff right here, just like when grandparents come to town and they give toys and gifts to the grandchildren, well, there has to be equal. You cannot give to one grandkid what you do not give to the other. So things that must be equal. It's also same for cooking. If you have a recipe that make 24 cookies and then you put in oven, 5,000 cookies will not come out. Only 24. So this what is called balance of mass or conservation of mass. So whatever you start with, you have to end up with. Now, if you look at this, this is chemical equation, like recipe. And if you look at it right now with careful, critical Russian eye, not Donald Trump eye, because he would just look at it and say, balanced, it's good, or something stupid like that, and say, no, this is fake chemistry, fake news. I don't know what to go with that. But if you look at this and you say, well, look, we have 4 phosphorus here, we have oxygen of 10 and 1 here, that means 11, and then we have hydrogen of 2 here. But if we go to product side, look, 3 from here, phosphorus there's only 1, and oxygen there's 4. This does not equal. Maybe in Trump world it's equal, but not in real world. It's not equal. So this is not considered balanced. Which brings up next question. Okay, how do you balance? Okay, well, it's very simple. First, there's rules. Number 1, and I believe you have seen this before. Number 1 rule, you want to balance metal atoms first. So metal atoms. But looking here, there are none. There's no sodium or iron or crazy stuff like that. So how about number 2? Number 2 is then balance non-metal atoms. Okay. That we can do because phosphorus is technically non-metal. So there are 4 here, there's 1 here, so we put 4. That means that, now in just a little secret Russian tip, you cannot change little numbers. They have to remain same. Because remember, they are balanced compound, they all add to 0. You start changing those numbers, no add to 0. So we can only change what's in front and tell us the quantity of this entire thing we have. So 4, that gives us 4 phosphorus. Okay, so we have 4 here, 4 here, that's good. Now we move to hydrogen, and we do that one next. So hydrogen, we have 2 here, 4 times 3, that's 12. So we put 12 here. How many do we have here? 6 times 2, so 12 here as well. So we got 12, 12, and those are taken care of. So off the board. It's great. Then finally and ultimately, if there is no rule you remember this one. You always leave oxygen last, because oxygen causes most problems. So here we have 10 plus 6, that makes 16. Okay, so 4 times 4, guess what make now? 16. That is fantastic, yeah? So now everything is balanced. We have same number on both sides. So now this is considered balanced equation. And you read it or not like a recipe. So if we have 1 mole of this, it's going to eventually make 4 moles of phosphoric acid, which is very yucky stuff. You do not want to get that on your hands. It's bad. This guy right here is farting. Yes, farting. Do you know that there are places in Siberia, Russia, that are so cold that if you were to take your papishka out and go pee-pee, the pee-pee would freeze into ice cube before it hit ground? I bet you did not know that. That's cold. You guys look out here and you're like, oh, it's 50 degrees. It's so cold. I laugh at your cold. Try going 50 degrees below Celsius. That's freaking cold. Now, what we are looking at here is a couple of rules that govern the behavior of gases, and yes, it applies to farts as well. There are 3 rules, 3 relationships between pressure and temperature. What do you think relationship is? So if I make gas hot, what do you suppose happened to pressure? Does pressure go up or does pressure drop down? What do you think? Pressure would actually go up. If you heat the gas up, it's like basketball on a really hot day. You leave out, you go out to play, all of a sudden you shoot, bounce off rim, and fly far away, because basketball now have lots of pressure because it's hot. So very good. This is very good. So now we have, how about temperature and volume? So if temperature go up, what happened to volume? Think maybe hot air balloon. Up in the way, in beautiful hot air balloon. Would you like my singing? No? Fine, Putin will come for you. So we make air hot in here. What happens to size of balloon? It gets bigger. So if temperature go up, volume also go up. Important note. Did you know that if air is too hot, airplanes cannot fly? Over 120 degrees Fahrenheit, if surface temperature is, airplanes cannot get off ground. Which makes you wonder, how the frick did they get anywhere in Dubai? Just thinking, I saw airplane fly across classroom. I just thought about that right now. So, temperature and volume. Now, how about volume and pressure? What would those be related? Now, you may have taken, like, let's say, a syringe. For all of you drug users out there, now I'm kidding. I kid. It's not drug users. Okay. But if you were to take syringe, like plunger right here, and put finger on top, like right here, and then you try to push down, what happened is you realize, wow, I cannot push very far. I push, but it's not going all the way down. That's because you are squashing squashing volume, and if volume goes down, the pressure starts to go up. Right? Yeah. Of course. So those are three relationships that go on between gases. So get those in your head. Remember, syringe, hot air balloon, and this one's like basketball on warm day. Now there is also something special about gases that are at STP. Not that you can really have a cold fart, because you are, well, you keep your body temperature constant. But if you could make fart cold at 0 degrees Celsius and at 1 atmosphere of pressure, which, just to give you a little heads up, 1 atmosphere is what you are experiencing right now. At 1 atmosphere of pressure, this is called STP, or standard temperature and pressure. It's very special because here's why. You could take any gas on the planet. Helium, nitrogen, methane, which, by the way, is but fart gas. If you've ever seen blue flames, you ever seen that, where people put lighters up next to their butt and they fart and they make like flamethrower. They come out. Does that work? Yes, it does work. You should look up on YouTube. No, now. Later. You finish review, then you look up butt fires. Okay? Because at 1 atmosphere, and you have 0 degrees Celsius, if you have exactly 4 grams, and that's the molar mass of helium, is 4 grams per mole, then the volume right here is 24.4 liters. So 1 mole of any gas, this goes from helium, nitrogen to fart gas, will all be 22.4 liters if at 1 atmosphere, 0 degrees Celsius, and 1 mole of material is inside. Just like little special ticket there. And so what if I have 4 moles? If I have, let's say, 4 moles of methane fart gas. I just like saying fart gas. It's just fun. You should try it in your head right now. Say fart gas. You'll do it twice if you do it once. So 4 moles at STP, let's say, of methane, that means I could multiply this times 4. And that means I can multiply this times 4. So if I have 4 moles of STP, the volume of the gas is simply 4 times this special number, which gets me something like what? 6 carried 1, 9, 8, looks like 89.6 liters. And that special funky function that only you can enjoy. It's be special. And it only happened at the STP. So now is time because you have been winning so hard at this video. It's like Trump, he win so much. People get tired of winning. He's so much winning. But now it's time for winning.
Masaluke is inside the penalty area as well, and it heads over to Masaluke. Look at him. Keeper goes on the adventurous route. Masaluke scores!
Bring it into a fist. You can do one of these. Great for pointing, giving directions. You can beckon. It has a fancy pinky mode.
But not yet, because you are doing live. You'll have to wait for videos. Okay. Now, these right here, they have this thing called, they call it the KMT theory, which is called kinetic. M is for molecular theory. The kinetic molecular theory simply states that if you make stuff hot, you will make the molecules move around faster, and then the reactions happen faster. That makes sense, right? Like speed dating. I would say if anyone here speed date, but I don't think that's really possible yet. But high school is sort of like giant speed dating. Look, you are constantly surrounded by people who are interesting and fun, and you sit down, you're like, no, not for me. And then, you maybe move on. Although most people would argue high school is for learning, not speed dating. But, it's same idea. So you sit down, and the more people you come into contact with, the greater the possibility of a love connection happening. Same thing with molecules. Though you make them hot, hot simply means move faster, which basically means there's no such thing as cold, only moving slow. You, my friend comrades, have been lied to. You have been lied to. There is really no such thing as cold, only slow moving particles. Your brain translates it as cold, but it's not. It's actually slow molecules. That's when you turn on the air conditioning. What air conditioning does, just kick out slow particles, that's all.
What about ice?
Ice is very slow. Very slow. Solids have very slow cold vibrations, so they don't move around much at all. Now, if you were to touch, let's say, the molten thermite, the molecules, although they are becoming solid, are vibrating so fast that they would tear apart your skin. They would bump into the skin proteins and break them apart and make ouchie. Big ouchie. I want to go back because Kevin is so hot. But he won't go back. Please go back. I want to see Kevin. Kevin is so hot. Actually, I make typo. It's actually Kelvin. There are two temperatures that chemistries like to use. One's Kelvin, the other is degrees Celsius. Frankly, I'll just put C here because can't really spell Celsius. It's very difficult for me to spell much of anything. So Kelvin is based on zero temperature. It's all absolute temperature. So at 0 Kelvin, there literally electrons start moving. Everything falls apart. It's like so low temperature, there's no kinetic energy left. Zero, zip, zero, nothing, zero, nada. So at 0 degrees, everything stopped. Now Celsius based off of freezing point of water. Well, what is freezing point of water? 0? You are correct. 0 degrees. And 100 degrees is where water boils. So Celsius based off of water boil. But Kelvin, water freeze at 273 degrees Kelvin. So if you want to convert between the two, if you want to know what is Kelvin temperature, well, you take the Celsius and you add 273. That's it. Not more complicated than that. If you have Celsius, want to find Kelvin, then you subtract 273. Piece of cake. Now, the solution, I would like to go back because pretty rainbows will come back in a second. A solution involves, well, a container like this and a fluid. Now, the stuff, the water or whatever this stuff is, that is called the solvent. And the little teeny things that are dissolved inside the solvent is called solute. I really don't like that word. Solute. Now, if you have lots of solute, lots and lots, you have a high concentration. And that concentration, at least in terms of chemistry, is referred to as molarity, which is basically the number of moles you have per liter. Then we know what moles are. We just talk about that. And you know what liter is. So this is basically a solution, has a solvent, a solute, and if you have lots of solute, you have very high molarity. This is something you definitely know what is. So if I ask you what is neutral on this, what would you say? 7 is correct. Caillou is very good. Smart group of American kids. Very rare. So, actually, in Russian, you spell like this. C. What's it called like this? C. I have to draw it backwards. N. No, that's not. That's correct N. C. No, that's correct N again. Okay. There it is. That is how spell 7 in Russian. That's siem. You repeat after me. Siem. Siem. Very good. Now you say 7 in Russian. Okay, so these very acidic, lots of H pluses. These very basic alkaline, lots of OH minus. And these two cancel each other out, as you are aware. But every time you go between, you increase concentration by 10-fold. So 5, 10 times more concentrated than 6. 4 is 100 times. 3 is 1,000 times more concentrated. So every time you go up number, you increase by a factor of 10. This is called, I don't want to write this down because I'm going to misspell. Log R-I-T-H rhythm. I am going to pretend that is correct. This is called a logarithm function. Anytime something increased by a certain base every time you go up a number. This basically is acid-base reaction. See here, here's acid. It has H out in front. There's base. Hello, base. How are you? You're fine. Okay, so we have acid and base react to make water and a salt. Now, this, ladies and gentlemen, happen every time. Every time acid base come together, what happened? Well, You put like this, OH and H, and you get water and salt every time. Always water plus salt. Now the salt that you get depend on what OH and H are connected to, but anytime you have a positive and negative thing connected together is typically called salt. Now we are getting very close to end. So now we present winning. For you! Winning for you, because communists don't do a lot of winning because they got lost into Cold War in 1991. So you win right now. So in this case, when we are talking about the focus power, we're talking about concentration. Not the kind where you'll like, oh, I'm going to focus my brain really hard to get answer on test. This is basically where we take numbers of moles and we divide it by how much fluid moles are dissolved in. And if you remember what that word is called, anybody remember what word it's called? No? Oh, there it is, molarity. That is correct. I don't know what that word is in Russian. Molarity, I don't know. I don't even remember what this was. Not everyone is equally as hot as one. Which is true, not everyone is, but some people have nice personalities. But I forget what this actually was. Not everyone actually hot. I guess we'll just say, okay. Smiley face, move on. So now, for end, I will play for you epic boss moves. So enjoy.
Everybody fucking
I don't give a fuck, I don't give a fuck, I don't give a fuck.
Jumpers are away,
Transactions, please press 1.
like a boss. Oh yes, I keep the bank.
Kiss me out of the bearded barley nightly beside the green.
7 cents. For your last 10 transactions, please press 1.
Like
Listen, you want lasagna for dinner? I got us a winner. I'm thinking about a little pasta with some sauce in the center. Maybe some parmesan, some mushrooms, and a garlic, and a little bit of bacon, and a couple small tomatoes when I make it. I'll put it in the oven, it'll be so heaven yummy. We should probably give a slice to everybody.
7 cents. For your last 10 transactions, please press 1.
like a boss. Oh yes, I keep the bank rolling. Like
It's the motherfucking Eagle Double G. Snoop Dogg. You know what?
two to the one, from the 1 to the 3. I like good pussy and I like. Like a boss. Oh yes, I keep the bank rolling. Like a boss. Sipping lean.
A suitcase, band-aids, pulling back out the driveway. You go, I'll stay.
Maybe you could show us how this light travel works.
Adios, aloha.
When you gonna...
I'm already back.
Start the day, wake up on the bend flex. Every girl together, we can still do it best.
Please press 1.
Like a boss. Oh yes, I keep the bank rolling. Like a boss. Sipping lean, big paper holding. Like a boss.
Oh, what a perfect circle.
Congratulations.